Now let us talk about linked list. Like a linked list, that seems to be a very easy data structure to learn. But yeah, there can be some complex problems in that as well. We will be learning in a very easy way. So first, let me create a new folder, linked list, and here I will create a new file, linkedlist.ts. Alright. Let us understand what is a linked list. So linked list is a linear data structure again. The stack was linear, queue was linear, the linked list is also linear data structure where elements are stored in nodes and each node points to the next node in the sequence. Okay, so I will explain you what is a node actually. And unlike arrays, linked lists do not store elements in contiguous memory locations. Right? I will explain you everything that I have mentioned. Okay. So a list. Okay. Linked list. I know a guy who knows a guy who knows a guy who knows a guy. Okay. There is a guy named Rahul. He knows a guy who is named as Rajesh, who also knows a guy named Raman, who knows a guy named Rahim, who knows a guy named Prathamesh, and who knows a guy named Jay. So here the head part, Rahul, because from him the list is starting, and he points to Rajesh for his request. Rajesh points to Aman so that he can fulfill Rahul's request, and Aman points to Rahim so that Aman can fulfill Rajesh's request, who is fulfilling Rahul's request, and Rahim points to Prathamesh because Rahim wants to fulfill Aman's request, who wants to fulfill Rajesh's request, who wants to fulfill Rahul's request, and now Prathamesh wants to Jay, who is the tail, who is finally the guy who can solve the problem. Now the Jay solves the problem, and Prathamesh's work is done. He tells to Rahim. Rahim's work is done. He tells to Aman that the work is done. Now Aman tells to Rajesh that the work is done, and ultimately it reaches the head, the actual concerned person. Alright. Head and tail. And what are these? These are nodes. Okay. So this Rahul, Rajesh, Aman, Rahim, Prathamesh, Jay, these are all nodes. These are the parts of linked list. These combine to create a linked list. Alright. Now, let's implement this linked list using Typescript. So what I'm gonna do is that I'll create a node first. Class. Oh, wait. Here I go. Class list node. Generate T. And here some kind of data will be there in this linked list. It can be of type T, and that doesn't matter. And next, this will point to the next node, and this is again a node only, node T. Alright. Or it can be null. Why? Because if this is a tail, then it will point to null. Now, constructor data of type T. Here, this dot data equals to data and this dot next equals to null. Alright, whenever you are initializing a node, the next will always point to null unless you explicitly specify that using the node dot next equals to another node. Okay, this is all in our node part. List. Now let us create a linked list based on these nodes. Class linked list t, and here private head list node t or null. Okay, so there will be a head. Alright, and now here we will also have size, private size number. So we will have a head, we will have a size. Okay, we are not specifying tail here as of now. What we will do is constructor. Now this dot head equals to null. Initially it will be initialized with 0 size. Size equals to 0. Right? Now let us implement the methods. Till now it is all empty. When you will initialize it, it will be an empty list. It has no nodes. So the first one is to add a node to this list. Here add is not the correct word, so I will say append. Append. And what are you appending? You will provide a data. This return X will be nothing, but it's your choice only. Ideally we should not return anything on these functions. New node equals to new list node data. Alright, now the node has initialized. If you have no head, what you do is that this dot head equals to new node, or let's say let current equals to head, and we want to reach a point where we get null. So as long as current has a value in its next, means as long as current is pointing to the next node, or as long as there is a next node, we want to move to it. Current equals to current dot next, and current dot next equals to new node. Means that as soon as we encounter a null value in the next, we stop it. Means that we have reached the last node, and in that last node the next will no longer be null, will be the new node, and this new node already has null. So that is how this will work. And finally I increment the size. This dot size plus equals to 1, or maybe plus plus as well, whatever you want. Okay, this is the append method for the linked list. Now we want to add an element, or add a node to the beginning of the list. How am I going to do that? Prepend data t void, and again let me create a new node. So I will be copying this, and I copy here. Alright, now what I will do, so new node dot next equals to this dot head, means the value in head is now the value of this next. Okay, and this dot head equals to new node, means this new node is the new head. Again, this dot size plus plus. So what happened? First I created a node, then the value of the node next will be head. Why? Because all the upcoming nodes will be starting from head. Why? Because we are going to make this our new head. That is why. Now I will be adding an insert method, so that what if we want to insert a node at a specific position? Okay, insert data t and position number and boolean. Means if the position is valid, it will be inserted, otherwise it won't. If position is less than 0, or if it is greater than this dot size, return false. Okay, we don't want to do anything in this case. Otherwise, if the position is 0, means we want to prepend. And like this. Okay, or maybe like we want to return the boolean, so what I will do is I will return true here. Okay, now what we are going to do is that let's create our new node, new list node data. Alright, now let current starts from head and previous equals to null and index equals to 0. Okay, now as long as we have not reached the position while index is less than the position, priv equals to current equals to current dot next and index plus plus. Alright, like this. So it means that since current has moved to next, the previous value is now set to the current. Why? So I will show you why. You have the previous value, you have the current value now. So new node dot next, all the next value will start from the current. Okay, and ref dot next equals to new node. Alright, like this. Means the previous node will now have all the next values starting from this new node. Okay, and increasing the size. This dot size plus plus and return true. Okay, so wait a second. Yeah, this way we can insert the node in a linked list at our desired position. Okay, now What if you want to remove from your desired position? Let us do that. So remove at data, no, not data, this time position number. This much only we will require, and this will return either the type itself, or I mean not the type, I mean the return type will be the generic T. So again I will add this validation, just there is some difference here. This time I will be like, so return null, okay, because if the position is equal to size, then also I mean indexing will not go till that, so you have to return null in that case. Now initializing the current with head, and again if position triple equals 0, then this dot head equals to current dot next. Alright, else what will happen? Again let initialize previous with null. We have to maintain a previous variable as well. We have to maintain an index. So while index is less than position, wave equals to cur, and now current moves to next, and index plus plus. Now you have the previous and the current as well. Ref dot next equals to current dot next. Why? So this was the previous, this was the next one. Where did the middle one go? That one got removed. Okay, so that is how you do. Ref dot next equals to current dot next, means the next value will now be the next value of the next value. Okay, next value of the current element basically, not the next value. So the current element got removed and the next value is being set. Finally, what I will do, size plus plus and return current dot data, like this. Okay. Whatever value is present inside the data will be returned. Okay. Now what if you want to remove a node which has a specific value? Remove and the data T boolean. What we are going to do here, so let's initialize current with head. Now let priv with null. Okay, why are we having it? First, what we will do is that as long as current not equals to null, as long as you have a current value, what you will do is that if your current element has that data, then what you will do is that if you are still on the first element, if priv triple equals to null, then this dot head equals to current dot next. Otherwise ref dot next equals to current dot next. That is what we see here. This dot size plus plus and return true. If you have found, then this will happen. If you have not found, then what? Then the previous will become the current one and the current one will move to next. That is what will happen. Okay. And now if nothing happens, then we return false. So let me run through this function or this method, whatever we call it. So we have the current element, means we need to keep a track on which element we currently are, on which node we currently are. Okay, element or node is the same thing. We need to keep track of the previous thing because we have something between previous and the next one, that is the current one. That current one we have to remove. That's why we are keeping track of the previous, so that we can link the previous one from the next one, removing its link from the current one. Okay. Now if you are on this current element and its value is the same that you have passed, then you remove. Okay, if it is on first, then the head itself is removed. Otherwise you set it like this, means the current value is moved and this dot size actually minus, sorry, alright, and here also minus minus. Now otherwise, you keep moving on to the next one, previous to current and current to current of next. That is how you move. Alright. Now what if you want to retrieve the element at the specific position? Should we copy that? Get element at, alright, again, and what we are doing is that current is initialized as head, and now here what we will do, we will not do this, and we will do this because we are not going to now remove, right? I will also remove this previous thing. Okay, what I'm going to do is that I will just keep moving, and sorry, and I will also remove this. We keep moving until we get to that position, until we get that value. Okay, so we are getting that value. You can also like return the node itself, that is also completely fine. So now what's the issue? Okay, like this. Anyway, that is your choice. So I am currently returning this data only. Now what if we want to get the size? The getter for the size, return size. Now I want to check if it is empty, is empty boolean, and return this dot size dot length, or wait, size, sorry, yeah, it was a number actually, sorry, yeah. And now if you want to clear, how can I do that? This dot head equals to null, that's it. Size equals to 0, that's it. That is the whole implementation of a linked list. Alright guys, so now what we shall do, I am gonna show you. First we created a node which is responsible for combining and creating a linked list of these nodes, and then I created a linked list on top of those nodes, so it has a head and we are tracking size as well. In some linked list you may find the size is not tracked. Okay, so I mean this is just our implementation. Sometimes in lead code you will find that size is not there at all, so you don't have to panic, you can always calculate the size. How? By doing this, simple, nothing else you need to do. Now if we want to insert a node to the linked list, but where we want to insert at the end of the list, then we keep moving until we get to the last element, and then there we add this. Means if the next is null, means it is the last element, so we add this node. So we increment the size. Now prepend at the beginning, all the values of the head will be moved to the right side. Okay, now insert at a specific position. Now what you do, you move, you keep moving until you get to that particular position, and then there what you do, you move current to one position next, and next of the previous is your node. That is how you insert. Now remove at, removing at specific position. Now almost a similar logic, you just keep moving, but just that you remove the link through the current. Means the next value of the previous one, currently it was the current value, but now it will be the next of the current value. Okay, and now it decreases the size. Now remove if the current is not equals to null, otherwise it will be false only. Okay, so if there is nothing, then what will you do? So if the current value matches with the value that you have provided, then if it is still the first node, means previous is null, then definitely head will be set to this. Otherwise, keep moving. Okay. So here prev.next equal current.next means the middle one you removed. Okay, here we are moving, not here actually, here we are moving. Alright, now get element head same as remove at, just that we are not now removing anything, we are just getting the element. Now on these easy methods like get size, empty and clear. So that is how your linked list is working, guys. Now let's get to the business of how to actually use this. Alright, I will tell you how you gotta actually use this linked list. Const my list equals to new linked list, let's say number, and like this. Now list, sorry, my list dot append one. I just copy this 2, 3, 4. Alright. Now I prepend 8. Okay. Now actually one more method I want to implement here to convert it into an array. Okay. What I will do is that to array and first result like this, and let current equals to head. Now while current is not null, result dot push current dot data, current dot next, and return result like this. And you will understand why. So you will understand why. Now guys, CLG okay, I got this. My list dot to array. Now again my list dot to array. Okay. Now my list dot remove. What I want to remove? I want to remove 3. No, not 3. I want to remove 2. Again, my list dot to array. Let me run this code. Let's see. 1, 2, 3, 4. 8, 1, 2, 3, 4. 8, 1, 3, 4. And our linked list is working absolutely perfectly. Alright. This 2 array was just to like see the output properly. Alright. So yeah, our linked list is working fine. That is how you implement the linked list in Typescript and then use it. Alright. Now we will be moving on to our new topic, that is the binary tree.